somewhere about 25. There's a kind of tapering off of plasticity, and you need different mechanisms to engage plasticity as an adult. Plasticity can happen in these enormous leaps, just like they can in adolescence and young adulthood. So now you can kind of start to appreciate why it is the most important thing for adult learning. Let's talk about some classic experiments that really nail down what's most important in this discussion about plasticity. The brain is incredibly plastic from about birth until about age 25, and then somewhere about 25. It's not like the day after your 26th birthday plasticity closes. There's a kind of tapering off of plasticity, and you need different mechanisms to engage plasticity as an adult. Knowing how to tap into these plasticity mechanisms is very powerful. So, how can we get plasticity as adults that mimics the plasticity that we get when we are juveniles? Well, the Newton Lab and other labs have looked at this, and it's really interesting. The signal that generates the plasticity is the making of errors. It's the reaches and failures that signal to the nervous system that this is not working, and therefore the shifts start to take place. And this is so fundamentally important, because I think most people understandably get frustrated. Like they're trying to learn a piece on the piano and they don't know how, they can't do it. Or they're trying to write a piece of code, or they're trying to access some sort of motor behavior and they can't do it. And the frustration drives them crazy and like, I can't do it, when they don't realize that the errors themselves are signaling to the brain and nervous system that something's not working. And of course, the brain doesn't understand the words, something isn't working. The brain doesn't even understand frustration as an emotional state. The brain understands the neurochemicals that are released, namely epinephrine and acetylcholine, but also, and we'll get into this, the molecule dopamine, when we start to approximate the correct behavior just a little bit and we start getting it a little bit right. So what happens is, when we make errors, the nervous system starts releasing neurotransmitters and neuromodulators that say, we better change something in the circuitry. And so errors are the basis for neuroplasticity and for learning. And I wish that this was more prominent out there. I guess this is why I'm saying it. Humans do not like this feeling of frustration and making errors. The few that do exceedingly well in whatever pursuits they happen to be involved in. The ones that generally don't do well. They generally don't learn much. And if you think about it, why would your nervous system ever change? Why would it ever change unless there was something to be afraid of, something that made us feel awful, that will signal that the nervous system needs to change, or there's an error in our performance? So it turns out that the feedback of these errors, the reaching to the wrong location, starts to release a number of things. And now you've heard about them many times, but this would be epinephrine. It increases alertness. Acetylcholine, focus, because if acetylcholine is released, it creates an opportunity to focus on the error margin, the distance between what it is that you're doing and what it is that you would like to do. And then the nervous system starts to make changes almost immediately in order to try and get the behavior right. And when you start getting it even a little bit right, that third molecule comes online, or is released, which is dopamine, which allows for the plastic changes to occur very fast. Now, this is what all happens very naturally in young brains, but in old brains it tends to be pretty slow. So, let me just pause and say this. If you are uncomfortable making errors and you get frustrated easily, if you leverage that frustration toward drilling deeper into the endeavor, you are setting yourself up for a terrific set of plasticity mechanisms to engage. But if you take that frustration and you walk away from the endeavor, you are essentially setting up plasticity to rewire you according to what happens afterwards, which is generally feeling pretty miserable. So now you can kind of start to appreciate why it is that continuing to drill into a process to the point of frustration, but then staying with that process for a little bit longer, and I'll define exactly what I mean by a little bit, is the most important thing for adult learning, as well as childhood learning, but adult learning in particular. Incremental learning as an adult is absolutely essential. You are not going to get massive shifts in your representations of the outside world. So how do you make small errors as opposed to big errors? Well, the key is smaller bouts of focused learning for smaller bits of information. It's a mistake to try and learn a lot of information in one learning bout as an adult. If we actually have to accomplish something in order to eat or in order to get our ration of income, we will reshape our nervous system very, very quickly. And so I think that the studies that Knudsen did showing that incremental learning can create a huge degree of plasticity as an adult, as well as when the contingency is very high, meaning we need to eat, or we need to make an income, or we need to do something that's vitally important for us. That plasticity can happen in these enormous leaps, just like they can in adolescence and young adulthood. That points to the fact that it has to be a neurochemical system. There has to be an underlying mechanism. All the chemicals that we're about to talk about are released from drug stores, if you will, chemical stores that already reside in all of our brains. And the key is how to tap into those stores. And so we're going to next talk about what are the specific behaviors that liberate particular categories of chemicals that allow us to make the most of incremental learning, and that set the stage for plasticity that is similar enough or mimics these high contingency states like the need to get food, or really create a sense of internal urgency, chemical urgency, if you will. If you've heard previous episodes of this podcast, you may have heard me talk about ultradian rhythms, which are these 90-minute rhythms that break up our 24-hour day. They help break up our sleep into different cycles of sleep, like REM sleep and non-REM sleep. And in waking states, they help us, or I should say they break up our day in ways that allow us to learn best within 90-minute cycles, etc. Today we're really talking about how to tap into plasticity through the completion of a task or working towards something repetitively and making errors. The ultradian cycle says that for the first 5 to 10 minutes of doing that, your mind is going to drift, and your focus will probably kick in, provided that you're restricting your visual world to just the material in front of you, something we talked about last episode. Somewhere around the 10 or 15-minute mark, and then at best, you're probably going to get about an hour of deliberate kind of tunnel vision learning in there. Your mind will drift, and then toward the end of that, what is now an hour and 10 or hour and 20-minute cycle, your brain will sort of start to flicker in and out. You're trying your best to accomplish something, and you're failing. You want to keep making errors for this period of time that I'm saying will last anywhere for about 7 to 30 minutes. It is exceedingly frustrating, but that frustration, it liberates the chemical cues that signal that plasticity needs to happen. And it is the case that when we come back a day or two later in a learning bout, after a nap or a night or two of deep rest, then what we find is that we can remember certain things and the motor pathways work, and we don't always get it perfectly, but we get a lot of it right, whereas we got it wrong before. So that 7 to 30-minute intense learning bout, specifically about making errors, I want to really underscore that. And it's not about, as I mentioned before, coming up with some little hack or trick or something of that sort. It's really about trying to cue the nervous system that something needs to change, because otherwise it simply won't change. I think everyone could stand to enhance the rate of learning by doing the following. Learn to attach dopamine in a subjective way to this process of making errors, because that's really combining two modes of plasticity in ways that together can accelerate the plasticity. In other words, making failures repeatedly, provided we're engaged in a very specific set of behaviors when we do it, as well as telling ourselves that those failures are good for learning and good for us, creates an outsized effect on the rate of plasticity. It accelerates plasticity. Now, some of you might be asking, and I get asked a lot, well, how do I get dopamine to be released? Can I just tell myself that something is good when it's bad? Well, actually, yes. Believe it or not, dopamine is also released according to what we subjectively believe is good for us. So, make lots of errors. Tell yourself that those errors are important and good for your overall learning goals. So learn to attach dopamine, meaning release dopamine in your brain, when you start to make errors. Find the time or times of day when you naturally have the highest mental acuity, and that's really when you want to engage in these learning bouts. Then get to the point where you're making errors, and then keep making errors for 7 to 30 minutes. Just keep making those errors and drill through it, and you're almost seeking frustration. And if you can find some pleasure in the frustration, yes, that is a state that exists, you've created the optimal neurochemical milieu for learning that thing. But then here's the beauty of it. You also created the optimal milieu for learning other things afterward.